Well, good morning. We're here at Emerald Hill Skies and we're trying to track a comet. And let's see, my name's Doug, and what I did is I slept for 5 or 6 hours and then got up at 4. And I've been experimenting with some technology in SharpCap, which is supposed to allow you to feature track. Let me see if I can show you the part of the sky where we're looking here. Let's see, I'll get a screen here. We're looking for this comet in the northern part of the sky. If you look at the north azimuth here, North Pole, and here's the North Celestial Pole at the Ursa Minor, and this is where this comet is. It's Comet C 2022 E3 is ZTF. And I know that's a bit of a mouthful, but it was discovered at the Zwicky Comet facility, the Zwicky Transient Facility, I guess, ZTF, Zwicky Transient Facility. And this is a facility designed to do things like discover comets and other things that pop into view that weren't there before, so to speak. And it was discovered in 2022 on March 2nd. It's a long period comet from the Oort cloud, and I guess it would be like 50,000 years that it's been on its way. It's traveling very, very quickly. The speed that I ran across was incredible. 150 or 160,000 miles per second. Is that possible? Let me see if velocity, here we go. Velocity 57 kilometers per second. So maybe that's 150,000 miles an hour. Maybe that's what it is. It's some incredible amount of speed. Now, there's not any kind of danger for planet Earth, but this is a very large object. This is a comet, not an asteroid, so it's mainly a bunch of ice and gases and carbon dioxide and little, basically, ice particles that have gathered together and drawn in by the sun. And this is getting pretty bright. It reached a brightness of roughly a magnitude of 6. Magnitude 6 objects are maybe visible for somebody with great eyes, and we're hoping it'll actually become just a little bit brighter, probably around February 1st or so. It'll be perhaps at its brightest. You could look for this object yourself if you just look in this region of the sky. Let me back off again and show you. If you were to look at the Little Dipper, and I guess this would be the cup, and then go a little bit farther out from the same curvature, you could try to see this, but it would be tough in binoculars. I understand binoculars just maybe a little bit out of sight. Now it's moving very quickly, even in the screen that we have it here. Let's see if we realign with the object and slew to it. Let's go to look at a live view. This is a live view. What I'll do is I'll put these crosshairs on it, and that'll show us roughly how quickly it's moving, because these crosshairs will remain roughly the same. And let's reduce our gain a little bit so we don't get quite as much noise. Let's come down to maybe 450 or so. And that's the comet right there in the middle. You can see that all the other objects will remain stationary, whereas this object in the middle will not. Let's maybe lengthen our exposure to maybe 3 seconds. And I know that we won't be able to live stack for very long, but let's just try live stacking this. I'm going to just check here and see how our audio is. Yeah, that's good. We hadn't really publicized this live stacking, publicized this stream any at all, because like I say, we got up in the middle of the night. Let's drop our reds now a little bit to match the other. And then let's drop our reds a little bit more. Nice satellite trail there in the middle. See how the object has moved off of that center where we had it. And that, of course, shows the fact that it is a comet. This is kind of an ugly picture, isn't it, with all those satellite trails. Let's just stop the live stacking for a second and go back to live. But you can see how far the comet has moved. What we'll do is we'll go back over to Stellarium, which is our planetarium software, and we'll zoom in, and that'll show us also the movement. Like there is our RASA, and this is our entire field of view here. Let's click there and slew back in the middle. So now you see we're aligned. Zoomed in pretty closely here. But look how quickly this comet is moving. Now, in terms of a tail, I don't know if we go maybe to a longer exposure here. Let's go for a 7-second exposure. You can see kind of a general brightening around it. But it doesn't really resemble a long comet tail, does it? Let's go back out to maybe 10 seconds. Let's reduce this gain down to about 200-ish. Maybe even, let's go 100-ish and try a 20-second exposure and see what that does for us. Down here at the bottom, you can see the bar graph representing the length of time of the exposure. We're using a RASA 11, and you can see there's the view in the observatory. That's a real-time view of our RASA 11. It's an 11-inch Rowe-Ackermann Schmidt Astrograph. Get rid of this kind of got a greenish tinge, doesn't it? And look how it moves even during the 20 seconds. You can detect a little bit of blurring, can't you? That's how quickly this object's moving. Whereas look, the star points are just as round and as perfect as can be. And this thing moves so quickly. Let's bring our gain back up to maybe 200. We're not using any darks or flats here. we're at 184% there. That's brightening it up a little bit. Look how much of a movement you get just during a 20-second exposure. Let's drop this down to 15 seconds. And see, there's a distinct green color, isn't there? Even though I'm kind of color deficient. Angela, good to have you on from Glendale, Arizona. What are you doing up in the middle of the night, Angela? But glad you're here. Angie, I guess you go by. You must be working late night shift. What would it be there in Arizona? Is it 3 a.m.? Okay, so let's drop this down to maybe 10 seconds, and then let's try again to live stack this. And I'm going to do a rough balance there. Let's color balance this as best we can. Bring our mids back down and bring our wow, look at the way at 10-second exposures am I imagining this, or basically is the comet moving that much within 10 seconds? Put our blocks about right there. Seven frames stacked. Now I'm trying some feature tracking here, and I'm trying to use the center of mass, but I don't know how well it's doing. I'm trying to track it, you know, using SharpCap's feature tracking, but as you can see that it failed at least some here, because it's basically tracking two things, isn't it? So that's just the let's go back to live view here without stacking for a minute. See if we can't. "15-second exposure at f200. Let's bring this up to a gain of 300. Just trying to experiment. Try to pick up a little more of the coma, a little bit of a tail maybe. There's 400 ISO. This is actually at 100%. So you see a lot of grain, but that does reveal a little bit more of the coma glow around this comet. That's a full frame view. So you see a little bit of the glow around it here. Experimenting with this, tracking to see if we can guide on the comet itself, which would be interesting. Let's try it again now and see if using the center of mass, looks like there's a tail this way and a little bit of a tail this way. Boy, no, we're not able to guide. This is an experimental tool anyway, this feature tracking in SharpCap. It's kind of trying to guide on the center of mass, and for those who are interested, I'll go back to using image features now. It's really big, almost looks like a planet, doesn't it? There's a little, looks like a satellite trail or meteor. These are 15-second exposures. Stu, good to have you on board. Thanks for the encouragement. This is, you know, you get experience. It's only my second comet. You kind of get experience by doing, don't you? So now we're tracking on all the stars, which doesn't help us a bit on the comet, obviously. It does kind of help keep the stars perhaps a little more points of light. Tauranga, New Zealand. Yep, the best way to learn. That's right, Stu. I don't know if we let's do this display histogram reset, and let's try once again to do live stacking just to see what it's like. Why don't we reduce these to 10-second exposures. At ISO 400 and try to live stack this. It's about 611 here. Oh, we're just not able to live stack. Look how much it moved in just that short amount of time. Or it could be part of these tracking realignments, huh? Let's see, there's a nice color balance. Let's clear our live stack here. Start over. Let's see, a new color balance. We're also going to be hitting daylight here soon. It'll become daylight in about, we'll start getting a little bit of daylight in 15 minutes or so. Now that's a little better view, isn't it? Yeah. I wonder if we bring, there we go. So these are 10-second exposures. Now you're seeing a marked tail. Tommy, you're in your work parking lot about to get clocked in. Okay, we'll do a picture of this. Now look at this tail here, pretty extended, and then the coma scattering out on either side here. A nice satellite trail, thank you. Whoever put that satellite up. let's bring these mids up a little bit and see if that brings out that tail a little more. Boy, it does, doesn't it? Again, we're using live stacking. Look at this, looks like a longer tail here, just barely visible. Of course, the tail is all the ice and stuff being blown off by the sun. It's not so much the movement of the comet as it is the, what would you call that, the ionization of all the ice particles. Elon, yeah, that's probably who it is. Elon Musk, you're right, Stu. Actually, with a comet, I'm wondering if it's better to keep this black level defined a little bit this direction so that we can pick up the tail and let the head, let's just let the comet core blow out. So that we can pick up, you know, the tail for a minute. Now at this point we're starting to pick up a lot of the atmospheric noise. We're observing here from the outskirts of Louisville, Kentucky. There's a lot of light pollution. There you see a beautiful picture of the tail. A lot of light pollution here, so we're using a Celestron light pollution filter that's designed for the RASA 11. And that cuts out a little bit of the light pollution, but boy, it took us a little while to get this set, didn't it? But part of that is just my inexperience with comets. I often tell people I'm an explorer, not a guide, because I'm so new. I looked in a moment ago as my 103rd observing session, but only my second real comet. So this takes a little bit of a tightrope, doesn't it, of figuring out, okay, so what are we going to emphasize? How long are we going to take the exposure? But you can definitely see an extension now, very long out there into the vastness of the solar system. This comet's going to be closer and closer. Let's see, I can't remember if it's closest to the sun on January 12th, but it'll be closest to the Earth on February 1st. And at that point, it's still a fourth of the distance between the sea. It got brighter than magnitude 6 and is dimly visible with naked eye, as long as you have a really dark sky. But with binoculars, you might be able to pick it up. It was discovered by Bryce Bolin and Frank Massey at this ZWO Transit facility. Isn't that facility in Hawaii, maybe? I'm trying to remember. Or is it in... No, it's in Palomar, Mount Palomar. And it's just a constant survey of the sky. So you get that strong solar wind that's causing that coronal mass ejection. You get this there was a bit of a broken tail as of January 17th. I don't know if we're picking up a broken tail, but it's definitely a beautiful, beautiful image, isn't it? We've managed to stack 31 frames now, so total exposure 5 minutes. Let's go ahead and save that exactly scene right now. Look at this tail here that's long, and then look at this inner tail, or whatever you want to call it, that's closest. Now again, our sunrise is coming. Oh, Stu, you've got rain there, sorry. Another one went past Earth earlier today, only 3,600 kilometers away. Don't look up, right? Starting to see a little bit of an extension now of the core because of the effect of live stacking, but at 6 minutes, this is a nice view, probably the best view we'll get of that extended tail there. For to get your bearings, our width of this frame is what? Roughly, is it 2 degrees? Let's go back over to Stellarium for a second. And we're not going to align to that. That'll mess up our live stack, but it's roughly, let's see, 2 degrees, 10 seconds wide by 1 degree and roughly 1.5 degrees high. So about 2 degrees wide by 1.5 degrees wide. So that's this frame. So about 2 degrees wide by 1.5 degrees high. So that tail now extending a little bit out of our top of our image, this narrower tail, if this is 1.5 degrees, is that the, oh, that's a huge tail, isn't it? Yeah, 1.25 degrees. So that would mean that this length of that tail that we're seeing is about 3/4 of a degree, maybe, at least a half degree. At least a half a degree long tail in this smaller tail. And then this brighter tail, of course, that's just exploding at maybe, what would that be roughly? If this is 1.25, so half would be 0.75. So in terms of decimals, this is probably 1/10 of a degree, I would estimate, on this brighter. Now you can really see the way the inner core is starting to leave a blur. We'll get one more save as seen. What a mess. Like, can you imagine being out there with this comet? And if you could hear a noise in space, of course you can't because it's almost a vacuum, but imagine this explosive, you know, all the ice and everything, and this thing is hurtling toward us right now. It won't get any closer than a fourth of an astronomical unit. It's not going to be close enough to cause any problems for Earth, but it is a fascinating story to see the way all of this ice and gases are peeling off because of the power of the sun. And you're seeing it here real time. 10-second exposures stacked one on top of the other so that you can pick up all of this live. Stu, that's really nice of you to encourage. Stu's saying, glad you got it. Glad I was here to share. Thanks for waking up in the middle of the night. Completely we hadn't promoted this live stream. I was just looking at the amount of, let's just show you here. Let's see if we look at our sky clarity that we're going to have. The red illustrates all of the cloudy skies, and the green illustrates when there might be a patch of clear sky. And we had roughly a 3-hour, 4-hour window here when there was some green. Tomorrow night there's supposedly going to be another 2-hour window, and all the rest of this is cloudy skies, completely socked in with clouds. So we got some sleep on the early end and got up at 4 and came in, and sure enough, we're able to catch this thanks to you guys getting up. Yeah, Stu's pointing out this thing won't be back for another 50,000 years. And I guess we'll call it at that. We're starting to see dawn coming here. Thanks for being a part of this. Again, this is Comet C 2022 E3 ZTF. Comet C 2022 E3 ZTF. And we're glad you're able to be a part of it with us. And with that, we'll go ahead and end the stream, but we'll keep on remembering this night and appreciate you sharing it with us. Good night from Emerald Hill Skies. We'll see you